Well, good afternoon, ladies and gentlemen. Thank you all so much for being here with us today. On behalf of AUVSI, I'm very pleased to welcome you to this afternoon's webinar, SL5200 and Twister, Advancing Unmanned Capabilities in Contested Environments. My name is Shannon Walker. I am the Director of Programs at AUVSI. And before we get started, we have a couple of housekeeping items that we always like to go over. So as always, the participant lines will remain muted throughout the webinar. We are recording this program, and a viewing link will be emailed out to all attendees along with a copy of the slide deck within the next few days. You can view and register for all of our webinars on AUVSI's learning and engagement platform, AVOL. If you are listening to our broadcast today and you need any technical assistance, please send a note to the webinar leader using the chat feature at the bottom of your screen. And after the presentations today, we are going to open up this session for Q&A. So attendees, you are encouraged to submit your questions at any time throughout this webinar using the Q&A button at the bottom of your screen. And the questions will be saved to be addressed towards the end of the program. Please note that the Q&A box is different than the chat. So just make sure you're submitting all of your content questions for our speakers using that Q&A button. All right, let's go ahead and get started. We would very much like to welcome and thank Silvus Technologies for their support of today's webinar on this really interesting and important topic. So we are excited to have three excellent speakers here with us today. Tom Bleier, the Director of Sales of UAV Systems at Silvus Technologies, Shane Murray, Director of Engineering at Quantum Systems, and Trent Emeneker, Project Manager of Autonomy at the Defense Innovation Unit. So we are in great hands today. We're geared up to get a lot of insightful information, and I'm actually going to go ahead and kick us off because for today's webinar, our speakers are going to explore how next generation MANET radio technology and eVTOL small UAS solutions are empowering the warfighter to achieve decision overmatch at the tactical edge. So let's take a quick look at our agenda for today before I hand it over to our speakers. So Tom from Silvus Technologies is going to kick us off with insights into the Silvus's unmanned MANET radio systems, and then talk about how they're reshaping mesh networking technology for this mission-critical applications. He's also going to introduce you all to the Streamcaster Lite 5200, the next generation of this radio technology, and its purpose-built for integration into unmanned systems operating at the tactical edge. So we'll then turn things over to Shane from Quantum Systems for an introduction into their family of systems, a suite of versatile UAS that provide adaptability in dynamic environments. And then Shane's going to take us through a deeper dive into Twister, which is a compact short-range eVTOL UAS that delivers real-time intelligence, AI-powered awareness, and support for integrated operations. So he'll be providing insights into the integration experience and the real-world performance results that they've had. And then rounding out today's webinar, Trent Emeneker from the Defense Innovation Unit will be providing an update on the Blue UAS Refresh Challenge and that program as a whole. So as I mentioned, we'll be taking questions at the end, so get them typed in and sent over as they come to your head. But with that, Tom, I will hand it over to you.
Okay, thank you very much. I appreciate it. Well, first of all, I'd like to thank you all for attending today. I think this is going to be a great group of people speaking, and then also some very interesting information for you all. And let's take a step back for a second. Why are we here? Well, there's a lot of change we've recognized in the Ukrainian conflict. The modern battlespace is becoming more distributed, more mobile, and more lethal. Near-peer adversaries continue to develop and deploy advanced electronic warfare capabilities at an even faster pace. The ability for unmanned systems operators to execute their mission, communicate, and share data to achieve decision dominance in a contested environment is mission critical. It doesn't matter if you have a cardboard drone that can be very cheap, but if it can't get there and do its job, it doesn't work. Same with drones that cost a lot more. The SL5200 radio that we're introducing today has the same system-on-a-chip architecture as our Streamcaster 4200 and 4400 product line that enables continual advancement with emerging features that will allow our OEMs and their customers to stay ahead of our adversaries' threats. The magic is that a radio with such a small swap has the industry's best MN-MIMO waveform and battlefield-proven spectrum dominance suite of capabilities that I'll explain soon. Next slide, please. I'd like to give you Silvus Technologies because it's actually a really remarkable company. We've been solving DARPA hard problems since 2004. Started in Los Angeles with a PhD who is still our CEO from UCLA. They tackled some of the most difficult RF problems over the last 20 years, advancing technologies, finding out what works, what doesn't work. And then as time went on, they formulated our MN-MIMO waveform, introducing products in around 2010. And now we've grown since then. We have over 200 employees in 4 countries. And you can see on the map below that we actually have customers throughout the world at US and allied nations. The products are built, designed, and tested here in the US and certified for military standards, including a program of record as well. We also have been ISO 9001 certified since 2015 to ensure quality control. So we have this foundational built up company that started as an R&D company with leading edge capabilities. We still are working on several amazing new technologies through R&D contracts with the DoD. We serve defense, public safety, law enforcement, and also some commercial and even other types of markets. But today, I think the focus is going to be really on the unmanned systems and the ability to approach smaller and smaller devices in a IoT networked environment. Next slide, please. Silvus Technologies is the leading provider of multi-domain operations. It really does take a network fabric that's going to operate through multiple environments to be effective for today's challenges. We have experience from 70,000 feet to on the surface of the water, all bringing different RF networking challenges that require a robust architecture. As you see in this slide here, we also support urban areas, including even tunnels, subways, and other types of environments that are necessary for the different types of USVs, UGVs, and UAVs that we encounter. Oftentimes, I have customers come up to me at trade shows or potential customers that say, our military customer wants Silvus. We need to talk to you. Well, why are they telling them that? Well, first of all, it comes down to it just works. Our products, when given to a customer to evaluate and test against other companies' products, come back with a resounding win in terms of overall performance and ease of use. The other is that, as we've recognized now, beyond just the fundamentals, the ability to operate in a contested environment and even congested environments for the commercial customers is something that is increasingly more difficult, and that is an area where we shine. The key is, though, once you've started to work with someone who's integrated as a concrete key component in your UAV solution, you realize that having a great support team during the design phase, the test phase, production, and then subsequent demo events for the military at ranges, or even in the field in Ukraine, we support our customers, and usually there is no charge for that. So we pride ourselves on super sharp, typically former military communications experts to help you get the best out of your solution set. And at a fundamental level, it's also because of the robust waveform. I'm going to talk about architecture more, but the key is to recognize if you have a waveform that supports scalability to 550 nodes on one network, it's a pretty lightweight protocol. It's something that is scalable in a dimension that no other capabilities offer or other products offer. And then we also support even supersonic speeds And this is all future-proof by using a system-on-a-chip architecture. Next slide, please. Well, the Streamcaster MANET radios are really a unique architecture. If you see on the top bullet, effectively every radio is a transmitter, receiver, communications relay, and a spectrum analyzer built into every single radio. That is so important when you're really in the field in an ever-changing environment, is to know what's around you and where to focus your RF network. It's not subject to the limitations of a Wi-Fi chip-based radio. Almost all other radios are based on a simple Wi-Fi chip. Wi-Fi wasn't meant for having multiple drones flying in the air, for hypersonics, for super large scalability. Wi-Fi is an open public standard that essentially, because it is public, is easy to detect and to jam by adversaries. We've actually got our own MN-MIMO waveform that I'll talk about in more detail, but it's an important discriminator that we are not a Wi-Fi chip-based radio. The system architecture also includes flexibility and future-proofing for firmware updates, because it is a software-defined radio with a system-on-a-chip architecture that has both FPGAs for high-performance digital signal processing, but at the same time has a flexible processor so that we can add software features with licensable capabilities. And we have 4 of them in addition to the ones that I'm talking about now that are just going to be emerging soon. The key to you, though, is throughput and performance. So these radios do work at a level of up to 100 megabits per second and support encryption for military requirements, AES 256 and FIPS 140-3 level 2. The end result, though, is that what we've got here is a core capability with this architecture that is expressed in the radios that you see here with ruggedized versions. And then we have OEM modules as well, of which the 5200 that we're introducing fits in that category. The frequency range goes all the way to 6 gigahertz, and we have the ability to connect numerous devices and our VoIP capabilities so that we can extend LMR radios, work with cloud environments. And what is also really important is we have all the accessories needed, cables, antennas, and power solutions as necessary. If I can have the next slide, please. Thank you. The mobile network MIMO, MN-MIMO, coined phrase by us, is 20 years of advancing R&D that is providing the capabilities. It's class leading. We just simply give customers, prospective customers, a couple radios, let them try it out for themselves and prove it to themselves. We win on range and throughput over and over. We're happy to do it. It's easy. But what we then do is peel the onion a little further and recognize that in this environment, you need to have EW resilience. And that's where the spectrum dominance that I'll be detailing a little bit more. And then the scalability that I was talking about earlier. Some of the capabilities that we've innovated and bring to the market, including transmit beam forming. This gives you an effective 4x potential transmit power and range, all with the same base power based on using unique capabilities that we've developed. We also support expandability, so there's no fixed range, hop limits, or timing limitations. Hundreds of miles are oftentimes the distances that you can use our radios to communicate with. We also support adaptive routing, modulation, and coding. So this is a dynamically adjusting waveform to give you the best performance. Next slide, please. So spectrum dominance is interesting because this is exactly what the Army says that we need. And we've introduced this a number of years ago, but it's actually really critical because spectrum dominance is required for your UAV to operate in the contested environment. Let's go to the next slide. So spectrum dominance essentially is a suite of capabilities that are additive software licensable and provide LPI, LPD, and anti-jam capabilities. The first part is if they can't detect you, then they're not going to turn on the jammers. If they do detect you, then we have anti-jam capabilities. So we have 4 capabilities here. They're detailed on our website, and we can give you ITAR briefings on some of the ones that are ITAR. But fundamentally, at a high level, we have in the upper left corner of the diagram a power control capability to limit the amount of RF emitted to get the job done. It dynamically increases as a drone might fly further away, or as a drone communicating with someone on the ground might go further away. That keeps the RF footprint lower, which is protecting for the warfighters. Protected waveform on the right is a ITAR-based capability, and that one is essentially changing the waveform because we control it so that it is less detectable and then therefore your covert. On the bottom left is interference cancellation, and on the right we have interference avoidance. Interference avoidance is interesting. We already, with every radio, have the ability to let you see a screen that shows 6 different frequencies, even cross bands in our dual band radios. And then to look at the interference on a bar graph constantly as you're operating the network. Interference avoidance will jump to the best frequency in milliseconds automatically, so it doesn't disrupt the data communications. Interference cancellation is an ability that nullifies strong emitters that allows you to operate in contested environments. There's also other techniques that are effective in the battlefield that applies to. If you can go to the next slide, I'd appreciate it. So now the Streamcaster Lite 5200 OEM module. This is the breakthrough. You've taken all of those capabilities that are in larger devices and putting them into a smaller one. Next slide. So on the right-hand side, you'll see it's hard to, these aren't exactly size related images, but effectively compared to on the left side, the OEM module that has been deployed in thousands of UAS that are in contested areas. We have now a device that is 60% smaller, 50% lighter, and yes, it's still 100% Silvus and works with all of the other products. It's only 52 grams, and with 2 watts of output power and transmit beamforming, we're getting effectively 4 watts of performance with up to 100 megabits of throughput. It comes available in both single or dual band frequencies, starting out with L and S band now, and then later with C band. It still has a system on a chip architecture, so we can add more capabilities as we go further. Next slide. So if you're thinking of looking for a Group 2 performance and now want it in a Group 1 footprint, this is the product that you should consider. It comes with the application flexibility and ease of use for integration, supported by our system engineering team that has unparalleled experience. It also has ability through our support and training to help you get to market more quickly. And remember, because it is software defined and with a system on a chip architecture, you have a future-proofed capability so that as the adversaries evolve, we're going to be able to negate their attempts to jam and interfere with our performance. Next slide. So I'd like to thank you very much for your time, and by all means, please reach out to me or sales@silvustechnologies.com, and we'd be happy to give you more detailed briefings on this, set up evals, and to help you have the best UAS capability for your customers. Thank you.
Thanks, Tom. Appreciate that. So I'm Shane Murray from Quantum Systems. If we go to the next slide. So Quantum Systems, we were founded in Germany in 2015 with a vision for a fully autonomous UAS, really focused on aerial intelligence. And that's where we've been pushing as an organization, that the platforms come together and we provide that aerial intelligence across the battle space for our customers. We started in commercial aviation, doing mapping, and now we've expanded into defense and security sectors with our Vector platform. We started manufacturing expansions. So we started in Germany in 2022. We expanded into America and Ukraine. We have an office and manufacturing facility set up there. And then in 2023, we expanded into Australia to support some contracts we have over there. We've grown globally across all of our sites. We have over 300 employees now, and we're continuing to grow in 25 and beyond, completing out the organization. Our defense and security sector, we've delivered over 1,000 vectors across multiple locations to date. We're deployed in Ukraine and Colombia in South America operationally. We have deployed systems here in North America and Europe, along with Australia and New Zealand. Next slide. So Quantum's really focused on the family of systems that gives us a complete picture for expanded mission capability. We're looking at systems that interoperability is key, not just between our systems, but also other suppliers, such as loitering munitions. Using the Silvus radios, we're able to get that common operator interfaces and simplify the training for our operators. They're only having to learn one system, be able to fly multiple vehicles. All our vehicles are eVTOL, so we're able to provide our operators a really small, unimproved space to fly from. Can you go to the next slide? So these are really the key 3 systems we have today. The Silvus radios make up the backbone of the entire data communication between all the systems. And we really leverage that mesh network capability. We've had these systems deployed, as mentioned, in Ukraine and in Colombia. And we've been able to fly extended ranges in those contested environments because of that technology. We have proven our links with the Silvus radios out to 100 miles or 160 kilometers. And that really gives us an advantage for our operators to be able to fly at any range that they need to. The Reliant is our next generation long-range operations platform. It'll give us 10 hours of flight time. It's primarily going to use Silvus 4400 dual-band radios. And then we're going to install SATCOM for those longer range missions because the vehicle will be able to fly out to 500 miles. We are implementing the mod payload standards. And so both our Vector and Reliant platforms are going to use that mod payload standard so that we can have interoperability across the systems. And also easy configuration management. The Reliant will carry about 20 pounds of payload with fuel and payloads. So the operators have the ability to mix and match depending on the mission that they need to be able to run. The Vector system, this is our system that we've deployed to date. We have about 3 hours of flight time out of this for medium range operations. We're using the Silvus 4200 dual band radio on this. We have deployed it in Ukraine with the MAN-IA and MAN-IC, and we've flown over 40 kilometers in that environment and had no flyaways. The system was able to fly, command and control, full video, back and forth. So we've really proven out that the MAN-IA, MAN-IC capability with the Silvus there works across that contested zone for us. In Colombia, we're seeing daily operations down there. They are running 30 to 40 hours a week on our vehicles. And so we see a lot of dependability in our system that they're using there. In Colombia, we're also using it for relays. So we use ground cameras with Silvus radios, relaying them back up through our Vector systems, and then relaying them back to a command center so that the operators can get an operational picture of both the video from the vehicle and man-wearable cameras, and the ground crew can also get that feed. And so that's one thing that we've been able to really rely on with the Silvus radios is that ability to have a dependable link at 5 megabits a second at range. We're also adding on our vector system the NVIDIA Orin boards so that we can do AI at the edge with that platform. Our other latest system that we're going to talk a little bit about is the Twister. It's really meant for squad level operations. It's going to run the Silvus 5200 dual band and has about 90 minutes of flight time. We're looking at deliveries of this system in Q2 2025. But really the key of all of this is that Silvus data link allows all of these systems to interop in the same airspace with minimal training. Next slide. So Twister is really our smallest, most compact radio. And as we were building the system, we needed to find a radio that would maximize our capability without compromising efficiency. We did look at putting other radios in there, but with the combination of our other platforms and the performance that we tested on the SL5200, it really was the right choice for the platform. It is a lot lighter, so that also gives us an advantage here when weight is a critical component to duration. Next slide. So we did do some testing with the Silvus 5200. We took it out and tested it against the 4200 to find out if the performance would be sufficient, and we didn't have any degraded operations when selecting this radio. So we set up a ground station. It has a 4200 10-watt radio on a 6-foot mast. We did set the antennas at a 45-degree polarization to sort of simulate a handheld controller so that we could simulate the real-world environment that we would be operating in. We tested the range out to 15 kilometers, which is the typical range of the Twister that we'd be operating. And so we fitted 2 vehicles out. They were both our vector vehicles for ease of development. One was fitted with the SL5200 with a PIDSO single band antenna. And then the second one was fitted out with the SC4200 EP with an MPSL dual band antenna. We do realize there was a slight difference in antennas there, and you'll see that in the results as we go next. The real objective here was just to fly in multiple directions and record the performance and try and replicate what we see in a mission environment side by side with 2 radios in 2 vehicles that are similar. Next slide. So what we were attempting to do is to validate the system. We wanted to make sure that our video link was stable at an operational distance. We're running the stream at a full 5 megabits per second, and we wanted to make sure that that stream was solid. We took off from position 1, and then we flew over to the to position 3s, which is the looped waypoints. We flew clockwise and counterclockwise on those flight paths, and also trying to validate as the flight vehicle is turning, we get different antenna angles to be able to make sure that the link stayed stable. We captured all that data and did some post-flight analysis, which you'll see in the next slide. So this was really the results of the Twister and the 5200 in comparison to the 4200. So in the top left, we had that sustained 5 megabit data throughput, and we saw the link was stable and fluid video on all of them. We didn't see any choppiness. It was just a nice, stable, continuous video stream. And so the 5200 is the first item. Then you got the 2 4200s. We ran it both at 10 watt and 2 watt and saw the same performance against the 4200. In the top right and the bottom right show the receive and transmit signals of the 4200s and the 5200s. The top right represents the ground side receive signals, which would represent the transmit capability out of the 5200 or 4200. We see it was slightly worse on the 5200, and that's predominantly due to the antennas. We did go back and independently test the 2 antennas and replicated that difference so we can negate that out. So overall, the transmit power received on the ground side was similar between all of those radios in both 10 watt and the 2 watt. On the bottom right, we see it's consistent across the radios on the receive side at the aircraft. The 5200 and the 4200s are receiving about the same set of signal and continue to have good performance there. We do see a drop in the AC noise of about 5 dB, and that was confirmed with the antennas that we used between those two systems, so we could negate that out. Really, the main thing we saw between the two systems is in the bottom left. Here we saw the thermal performance improvement on the 5200 across operational performance. Even when we decreased the power of the 4200 down to 2 watts, we still saw it ran hotter than the 5200. So overall, you're about 5 to 6 degrees C better with the 5200 over the 4200s. And so what we really see is you're getting the same performance in a smaller package. And when we're getting down to those smaller UAVs, the 5200 becomes a nice choice so that we can get the weight down, but still get the same range that's needed for these devices. Next slide. So really, in conclusion, the 5200 is really giving us a Class 2 capability and a Group 1 footprint. We see that that's where we're going to head with the Twister, and really gives us those capabilities without sacrificing any efficiency or effectivity across that range. And so that pretty much concludes what we've seen with the 5200s across our family of systems. I'll hand it over to Trent now.
Thanks, Shane. So I wanted to thank everybody for the chance to come and speak about Blue UAS. Well, if you're all familiar with the federal government, you know that we buy things via a program of record, that's the normal way, or through something called an exception to policy, which is a paperwork-intensive, not scalable way to buy things. Blue UAS was created almost 5 years ago as a third pathway for validation of platforms and capabilities as being in compliance with the law. We look at them for NDA compliance and cybersecurity, and then we write an authority to operate. Once we do that, it can then be purchased, bought, and used by anyone within DoD legally. Now, we don't want Blue UAS to be the only pathway into DoD. It's not. ETP is valid, programs of record are valid, but there are complications with that. In order to address the problem statements that our end users have, because they're very clear about what their problems are, they base that off their lived experience, they base that off seeing what's happening in Ukraine and in a lot of other places, and they know they have gaps that they need to have addressed. We want to provide commercial capabilities that address those gaps. We know there's a need today, and so everything we do is focused around delivering capabilities to the warfighter, our end user, today, so they have something. Not perfect, not necessarily great, but good enough to allow them to train, develop the tactics they need, prepare for combat, and if called upon, go survive and prevail in combat. Because our partners want modularity and interoperability. Imagine if you're a company commander, battalion commander, you may only have a couple of drones. Well, you want to be able to put an EO camera on, or an IR camera on, or thermal, or a different radio, depending on the problem set that you're facing. Those are the kind of things that Framework does. And so if you go to our website, DIU's website, I'd encourage you to do two things. Number one, sign up for email notifications from DIU. In case we release solicitations to industry that you're interested in, that way you'll be the first to know. So a common refrain from industry that I've heard since I came into this role about 1.5 years ago is, you need to expand the blue list. We want to make the blue list. How do we get on? Well, there are really two pathways. Number one is by sponsorship from a DoD organization. If it is, we will go through how we could add you to the list. And on the list today, we have 2 Blue List platforms that were done via the sponsorship route. In the next 6 months, I anticipate adding between 3 and 6 more through the exact same process. The other way to get on is through a competitive entry process. If you're familiar with the history of Blue, you know, back in roughly 2020, we added some platforms. In 2022, we added some more platforms. Those were done in discrete chunks via DIU's commercial solutions opening, a competitive entry solicitation process. The Blue US refresh that we held last week in 29 Palms, California, is another way for us to have a competitive entry process, but to do it on a faster and more responsive timeframe. So it is our intent today that on an annual basis, if not more often, we engage in a competitive event to allow companies to compete for the chance to join the Blue List, to allow our current Blue List partners to demonstrate their capabilities, but also have to compete to remain on the list. There's no one who is guaranteed a spot. Nobody's grandfathered in permanently. We want to unleash capitalism in the free market to generate the competition that we need to give the very best options out there to the warfighter. At our most recent Blue US refresh, we had 360 different submissions from 225 companies. Of those, there were more than 600 separate things that were submitted because often a company submitted multiple proposals in one slide deck. From those companies, we selected 35 to come to the actual event last week. And we also selected another group of framework companies who are going through the verification process now for addition. So as we talked about, framework components, sensors, software, not the flying platform. The Blue List is the flying platform. We will continue to expand our framework to expand options for our end users. At the event, we had approximately 50 evaluators from across DoD, members ranging in rank from specialist to lieutenant colonel, chief warrant officer fives, brand new operators, very experienced operators, folks from program offices, services and combatant commands, all there to evaluate the platforms and give warfighter feedback on, does this meet my capability gaps or does it not? It's not being chosen by me. It's not being chosen by, folks sitting in an office somewhere. The feedback that the end users gave is what we are using to evaluate the submissions. And that's our intent to do going forward. I want end users to evaluate because they know their problem sets the best. As a result of that, we're in the process now of going through and making our final down select process. We are on track to finish by the end of this week, but that's not a time commitment that I'm firm on. It's just what we're on track to. I've learned, things always come up. Once that's done, then we will begin the process of NDA verification and cybersecurity analysis. That process will run from now, likely through March, potentially early April, as we look at all the individual platforms we are choosing to add. We're going to do everything we can to do that faster. We understand our commercial partners want to get their products on the list. We are just constrained by manpower and fiscal resources. But as I mentioned before, we don't want people to think of the Blue List as the only pathway to DoD sales. Exceptions to policy and programs of record. But in the broader federal government, public safety, industry, the other thing that we want to encourage is, things like AUVSI's Green List. It looks at platforms in the same way the Blue List does, and it provides a verified seal of approval. Now, I recognize the Blue List is looked at, as kind of the gold standard in industry. That's just the reality. But we want to encourage people, and I do this anytime I talk to our other federal agency partners or public safety, to look at other ways of seeing a verified platform that's not on the Blue List because their needs don't always line up to DoD needs. From there, my big takeaways for you, we know that Blue UAS is not a perfect thing. We know that we have to get better. And I always want to hear feedback. I get it all the time from our DoD partners. I get it from commercial end users. Believe it or not, we've acted on it over the past year. And that's partly what led to the refresh. So that we give our commercial partners a chance to on-ramp. We gave our DoD operators and evaluators a chance to see and get hands-on and evaluate what best met their needs. And with that, that's kind of my overview on Blue UAS. So I'll turn it back over to Shannon for any Q&A.
Perfect. Thanks, Trent. I'm going to get up the slide that I think we bypassed originally, but we want to make sure that we are able to cover because we actually got a question about getting more information and reaching out to you. So, Tom, if you'd like to cover this what's next step question, then I will move into Q&A right after that.
Sure, thank you. We effectively have data sheets and integration guides that are really helpful for anybody contemplating integrating one of the OEM modules. And we do have demonstration units. There's a list because it's very popular, but we definitely can provide a SL5200 so that you can try it out and then you put it on your UAV. And then we're really strong in system engineering consultation. We know that many companies don't have a principal RF engineer on board, and that's where we come in. Think of us as your RF engineering department. Give us a call. We have tools, we have experience that really nobody else has with the variety of customers that we serve. So you have some information there, or you can go to the site and then click on contact and fill out a contact form.
Thank you. Then, as a reminder to attendees, if you have a question for Tom, for Shane, or for Trent, please submit it using the Q&A button at the bottom of your screen. We've got a couple coming in already, so I'm going to jump right in and get started with those. So the first question, Tom, it asks, how does the SL5200 support the performance needs of smaller UAVs?
Well, the key here is that we have the fundamental MN-MIMO waveform. It really is very resilient. You all just heard that, unfortunately, Trent using a 5G system wasn't able to get really great audio and video through, just like in a contested environment, except this here in a congested maybe environment. So the key here is it starts with that basic waveform and then the spectrum dominance features. So that's how we can get that into the smaller UAVs. We worked on this well over a year to bring that down in size because we saw the need for attritable systems and for small tier 1 aircraft and other small UGVs as well as USVs that effectively we could do that. The other part of this is really important. The transmit beamforming allows you to essentially get a 4-watt performance out of that small module. It's less heat, that's less power, that's less cost, and less size, all because of digital signal processing that we've perfected for transmit beamforming. So in all of those things add up together to provide something that's more relevant given the SWaP-C constrained tier 1 products.
Perfect. Thank you so much for clarifying. The next question, I believe, will go towards Shane. Are there any issues with the mid-range and short-range UAS in rain or snowy conditions?
We haven't seen any issues in rain and snow. We have used it in all those conditions. In fact, we did recent demonstrations up in Alaska. We did see some issues with the pitot tube. And so one of the improvements we're working on right now is to put a heated pitot tube in all of our systems because that's really where the icing was forming and causing some issues. But other than that, the systems performed well in all of those conditions.
Excellent. Thank you so much. I'm going to bounce back and forth. So, Tom, I think I'm going back to you here. We just talked about congestion amongst the airways. So can you talk about how the SL5200 improves network connectivity for multiple UAVs that are in the field?
Sure. Well, the key here is it's back to the waveform because we can support massively scalable mesh networks. We also have some software features. You're all familiar probably with a broadcast. Well, in a mesh network, we have a special MANET broadcast capability so that it doesn't create additive impact as it propagates through the network. So that's a real important capability. The other one is that we have QoS capabilities. So what we do is we have our customers put the command and control with a high priority. Video would be a little bit lower. Voice is always a high priority for push to talk that goes through the network. It's very low bandwidth. But ultimately, if we were in a contested environment right now and we were sharing the video command and control, I've done tests where we essentially can see that the video will be allowed to degrade before the command and control, or even push to talk, because those are the most critical links sometimes.
All right, perfect. Thank you. Next question back to you, Shane. Can you confirm the channel bandwidth that's used for the Twister and SL5200 trial tests?
Yeah. The channel bandwidth was set up at 20 megabit, is what I believe that it was set at. But if the individual that asked the question could send me an email, I'll confirm that with the test team. But I do believe it was set at 20 megabit.
Perfect. Thank you so much. Okay, next question came in for Silvus. So for Tom, what are kind of the rules of thumb with regard to network bandwidth capability once a relay node is introduced? And what about when multiple relay nodes are involved?
Oh, that's a good question. Yeah, so ultimately, if you think of a data flow from A to B at 5 megabits per second, and then you're going through multiple hops, C, D, and E, it does aggregate the overall radio time on that network. And that's why, as I had mentioned previously, we have a special broadcast box you can check. And then for that port, what it'll do is it'll set it up so that you can have a MANET broadcast. And so then even if it cascades through multiple nodes, it's still going to only be an impact of a total of 5 megabits per second. This is how we were able to have cursor on target information propagating through a 550 node network, so that as it propagated through in a MANET broadcast, it wasn't additive as it moved through each multiple hop. So we have a link budget calculator that is available to our customers, including with videos of how to use it and other instructions. And we will help guide you to set up designs for networks, because there's certainly scenarios where you want a radio relay and a networked relay to go hundreds of miles. And so it might go air to ground, and then maybe even through other hops. And we've got some specific capabilities for multi-hop or multiple ground stations in a large area of coverage, thinking maybe Indo-Pac area. So we just contact us and we'll go ahead and we'll work with you online and use a link budget calculator, and then set up a design of your network that works for you.
Great, thank you so much. We're running through our list of questions, so attendees, this is their last plug to get a question in if you would like it to be included here today. So next question that we have is, what encryption features does the SL5200 offer to keep UAV communications secure?
Okay, well, that's another good question. So just so that everybody's clear, the baseline product is not ITAR controlled. So we can sell that anywhere. When we add certain features, we add such as enhanced encryption, the AES 256 that I was talking about. Once we get to that level, or the FIPS abilities, then it becomes ITAR controlled. It's a software license that we load when we ship the product, or we can even ship it later on, just email it to you on demand. And that's free. There's no additional charge for the advanced encryption.
Perfect. Thank you so much. Unless we get a couple of last minute questions here, we're going to get wrapped up pretty soon. So before we actually start to close out, Tom, Shane, I'd like to turn it over to you for any closing comments that you have for the audience.
Sure. Well, I'd like to first of all thank Shane and the team at Quantum Systems. We've built a great relationship over the years. The one thing a special forces operator told me at a trade show was, when we started out working and interacting with folks in Ukraine, we were teaching them a lot of things, and it flipped. So now we're learning a lot of things. It's because nothing like that environment for testing and evaluating and constantly recognizing that there's rapid evolution in going on. And so having close relationships with quantum systems allows us to get that feedback loop and then bring more and more advanced capabilities. Things that might be in beta, we can get to Shane and their team and then let them try it out in that environment. And then oftentimes we'll be there in Ukraine on the boots on the ground with our customers like Quantum Systems to then see how it works as we test against active or captured and active enemy jamming technologies. So it's really a teamwork. And I want to thank you all at the Quantum Systems team for joining us today.
Thanks. Yeah, I want to echo that statement. It's been a great partnership with Silvus. I appreciate everyone logging in and listening to us today. The thing for quantum is, right, we're trying to build really a platform that's robust in all environments. We've set up facilities in Ukraine to get live feedback of data, pass that back to Silvus. They make constant improvements to the product, and then we quickly deploy it back out. And we see that every day over there in the products, both our products and the backbone with Silvus, continuing to improve as we deploy that. That also just relates to better improvement for our local customers as well. They see the benefits of all of that testing, and we're holding a operator training and lessons learned event on how our operators actually use the system so that we can get feedback and information we can share with other operators. And just with regard to the relay question, you know, a lot of what we see with different radio companies is you see a lot of literature, but with our systems, we've been able to prove it. And we recently were down in Colombia doing multi-relay nodes with video streams, presenting to special operations down there, and it all worked flawlessly. So it's been a great partnership when we can all go out and prove that this technology actually works and benefits the warfighter. So I appreciate everyone's time.
Wonderful. Thank you so much for that. And you know, it's fitting we got one last question that snuck right on in, and it's for Trent. So let's give it a shot and see if his connection is strong enough. But Trent, the question that came in said, you know, I think you commented on this, but will the Blue UAS list expand to Blue UAS infrastructure?
I think that's a really interesting question. I'm not exactly sure what the definition of infrastructure is in the question, but if it is related to the components covered under law, so our critical components as defined by the various NDAs and the 2024 American Security Drone Act, we're already doing that. If by infrastructure you mean things like batteries or electric motors, today those are not covered under the law, and so that's not something we're directly going to address. We care very deeply about things like batteries and electric motors, though, because the supply chain vulnerabilities inherent from depending on China. That is a supply chain vulnerability. We recognize that, but it's not covered under the law today. If that's what was meant by infrastructure, then great. And I hopefully that answer will help.
Well, thank you so much. I appreciate the clarification. And if that isn't what you're looking for, you can connect on the DIU website and submit more. All right. Well, we are pushing up to the top of the hour. I'd like to once again thank you, Tom. Thank you, Shane. Thank you, Trent, for your time today, for this information. Really interesting, really useful and practical technologies here. So thank you also, Silvus Technologies, for the generous support of today's webinar. Really quickly, attendees, you will receive a link to access the webinar recording within the next few days. All of our webinar recordings are on AUVSI's learning and engagement platform, AVOL. So when you received the link to the webinar, there will be some additional information about accessing it, as well as a link to a copy of the slide deck. for those of you interested in seeing that more closely. If you have any additional questions or comments, please feel free to email our team at education@auvsi.org. And lastly, today's program is copyrighted by AUVSI with all rights reserved. So thank you all once again for your time today. We really appreciate it. Thank you, attendees, for joining us today. And we hope you guys all have a wonderful rest of your day.